a good podcast. I decided you can also join and share my knowledge. Oh, I'm already in the video.
So this is Cherry, aka Drona. More or less, we'll get to know in podcast.
So welcome back to Video Science Guys, a podcast by biomedical engineers, and I'm your host Giridhar.
And I'm Ashita.
And I'm Dipan Das.
So we have a new member here. He's Drona Cherry. So quick intro, guys. He's from IT. So he's one of the team members in Video Science team. So here he came like he have a lots of experience in IT things. He basically having some project works or something. So he's very interested in his field also. So he came here to explore over our branch, more than our branch. A quick intro, guys. Drona, a quick intro of you.
So, myself Cherry, aka Drona, and I am here with my topics. And I already saw their podcast, they are already uploaded 3-4 episodes, and those episodes are really good. So, I was also interested, and that's why I joined.
So claps, guys. So
Welcome, Cherry, to our
welcome
podcast.
to Video Science. You are already a team member.
But today
you-
we are revealing your face.
Yeah. So for today's session, guys, we have only two topics. First will be the Dipan's topic. So he's has some things to explain us about the decelerization and techniques, and like it's a big process. And Drona Cherry have a topic on quantum computing. So it's a team with multiple branches, guys. So
It's like if we are combining two brands right
two
now.
branches.
And now here we will explain how all those branches help each other to grow
Yeah.
and build something which is kind of awesome.
Okay.
Definitely. So everything will be like need to have some help, right? So when coming to medical technology, I'm just trying to link, guys. When coming to medical technology, it's not only about the hardware. They should have some software features, like as I talked about the Guardian AI, where it only takes sound as an input and recognizes whether the heart functionality is working fine or not. So this is the, like I'm trying to link two things.
Yeah.
So first we'll go through the Divine's topic.
Okay, then welcome everyone. So my topic was deceleration. So as you know that cell is the basic fundamental unit of the life. So then first of all I will explain that what is the meaning of deceleration. As you know the deceleration it means the removing all cells from a tissue or organ, and in outside it was only left extracellular matrix. That's the real meaning of deceleration. Like deceleration was the most complex topic in the whole that biology side and the whole medical side. It was very complex because we were doing that in nanoparticle cells. So that's the basic difference of decelerations.
So on my terms, decelerization is a technique where so we have some extracellular matrix, guys. So it's nothing but the it's the matter where it holds cells.
Yes.
It
Like a
keep on
binder.
organizing cells.
Like a binder.
Yeah, it's like a binder. So where it mostly useful for the reconstruction of new tissues or something.
It's like bind the muscles and the bones
Yeah.
together.
Yeah,
It's
it's
like a glue or a
glue.
magnet.
Yeah, it's a
You can
glue.
say. It's found, like we can find it everywhere in our whole body. For me, the deceleration method is a thing like we can use only extracellular matrix from our body, and then we can construct or we can develop a different tissue unit product from that, out of that. Because like in ECM there are so many things, so we have to first remove the excess thing which you don't need it. It's a process of, I think, removal of waste, you can say.
Guys, kindly requested. Here is the IT guy who have like minimum knowledge. So you're getting
Bored.
I was thinking about this, like you said about decelerization and all, and it is a binding material and all thing. I was thinking, like, see, if my eyes are having different cells, so their binding materials would be different, right?
No.
No,
ECM
or
is
every cell has the same binding material.
Same.
Same.
But the material changes.
But the material should change, I guess.
But the
Material-
material which the ECM binds, that changes, but the ECM is always the same.
Can you explain what is ECM? I don't know.
Extracellular matrix.
Okay.
It was present everywhere, you can say, like right now if our hand is attached to this place, this is
Mhm.
because of ECM. You can like just think
It's like the matter, like.
it's like a matter. Like
So, for example, take.
take a toy or something, na? That
No, that's too complicated example, I think.
okay.
See,
Okay.
have you seen the in structure, there are cells binding each other? Have you seen in structure, like bark of tree?
Yes.
The Robert Hooke has discovered that one
Mm,
cell.
the cells.
Have you seen the structure? There was binding each other cell.
Yes.
This was binding because of only that extracellular matrix.
Yeah.
That's
So
what I'm
if-
saying. Na? See, when we are binding different cells, if it is a tree cell, the material should be different. This is what I
See,
think.
Guys.
in the stationary things, you just use that one glue, most probably everywhere, okay? That one glue sticks with paper and like most of the components.
Oh, you're just like we use Fevicol, right?
Yeah.
We can
Yeah.
stick
Yeah.
paper with it. We
Yeah.
can stick clothes with
Yeah,
it.
and-
We can
and-
stick some toys with it.
Yeah,
Plastic. also.
ECM is like that only.
Okay.
In simple, like.
That was a good explanation.
Yeah.
Hmm.
In simple terms, it's like a PCB to build in the components.
Oh,
Where the PCB
Yeah.
attaches, combines the all components like
Yeah.
resistors.
And about those cells, we don't need our cells because like if we use that cell along with the ECM in something different, like in the process in which we want to create something related to tertiary product, so at that point we can't use our cell because everybody like we can say like everybody have their own cells, okay?
Mhm.
They have their own different identity like a DNA, and if you use someone else's cell over it, our body will reject that and it won't affect us and it won't help us. That's why we have to remove all the cells except ECM. ECM will be accepted by body because it's same
It's the
everywhere.
same forever. Oh.
See, I want to explain one more thing that can you know the why we need deceleration? Why we need that part?
Maybe because we want to do some changes or we want to improve it, or if there is a damaged cell or something, we can replace it.
What do you think?
Mhm.
Yes, yeah, these are thinking.
So,
See,
Continue.
okay. So I feel decellularization we need so that we can make different products out of it.
Okay. And what's up with that?
So I thought first, see, everything is made up of like in simple tissues were there.
Yes.
So every tissues have some cell in them. To gain what's the thing happening with that specific type of cell in that specific tissue, we use the not only cells were there in tissues. There is a matrix that we don't need. So to remove the matrix, we mostly wanted to use decellularization to get only what we want. So it's like picking up with hands
Yeah.
that we only need that certain part.
Yeah, it's something like we are going to the supermarket and we need only apples, so we just pick up the apples, not the mangoes.
Yes.
Yes.
Understood?
See, like when we place any heart, like on transplant the heart now, see that time now, when you, as you know that we have immune system in our body. So when foreign particle comes, it will reject that one.
Reject it.
So when the other like any other body cells come in our body, like say for example Jay's heart I transfer in my heart, okay. Then when it comes now, my whole immune system will reject it.
Yeah.
It will destroy the whole heart.
Yeah.
So to means if we are rid of that, we decellularize that one.
Okay.
And we build new cells in my whole body.
And in our body, we have one term that is called MSC. That MSC is like an ID card, okay,
Mhm.
in our body. These, like each and every cell has that MSC, okay,
Tag.
different tag,
Yes.
and like I have different one. Like my cells all have like different MSC. His is also different. Everyone is different, and if your MSC comes in my body will reject it, and like
But
it will
that's
destroy it or chop it off.
Okay. Along with that, there are liver transplant also,
Yes.
and
Kidney
like
transplant
kidney
also.
transplant also. That time there is something called, like, I don't know much, but there is compatibility.
Yeah.
Like if your liver is compatible to mine or not.
Biocompatibility.
Yeah.
Is it like why some livers are getting rejected by body and why some are not?
So let me explain it. So you heard about DNA.
Yes.
So DNA will not be same for everyone.
It's different from
If it matches, then you should be the twin. If DNA matches, it should be yours or it should be your twin.
Like DNA is totally different,
No,
right?
twins though I don't think they also have a different
They
DNA.
also have different DNA, but
But
it's compatible.
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 Compatible
Bone
DNA.
marrow they can use of each other in bone marrow.
And same goes for that blood also, right?
Yeah.
Some blood donor can donate blood, some cannot.
Yes.
But
That's why
that,
we need-
about that liver,
Hmm.
first you talked about that biocompatibility.
Yes.
About that, they first search for a person who is like at least you can say 80%, 70% compatible to that person who are undergoing for that transplantation, and then after transplantation they give some kind of drugs to the person, that implanted person, so that they can suppress, like they can I think you can say
Suppress the
sup-
digestive system
no,
from the body.
yeah, you can say that suppress the immune system. So that that MSC, that is major histocompatibility complex, like they won't attack that new things that happens in our body, and then after it will accept that thing.
And the main disadvantages of replacing own organs is immune system, where every organ has some things like major histocompatibility, where it denies to merge with itself. So where it comes like after denying, your immune cells will work very hardly, very active. If you have some heart replacement, anything like liver or so, like it's not yours, but you still got a similar like 70% match,
Yeah,
and your immune system will keep on attacking you,
yeah,
keep on attacking that organ specifically.
yeah,
On that case, this is the major disadvantage.
yeah.
When immune system hit hard,
Yeah.
the organ will get
Yeah.
failure.
And you have also heard like after transplantation, that patient, he is like also having different kind of problems. Sometimes that person got jaundice, some blood infection or different things because their immune system is very low.
Okay, so if somehow we master decellularization, we can tackle all this problem in one go.
No.
No.
It is very complex.
Okay.
So here decellularization is only used to pick whatever we want, then reconstruct it as per we like.
And that decellularization we are talking about, it is not successful, that much successful. People nowadays also just transplant and for different anything you can say for a human body, they just prefer human body things only. Not like a product which we creating, not for the animals, you can say genogenic, something like
Yeah.
different things. Still they are preferring human things only because these things are not that much successful.
So have you heard artificial meat, guys? Have you heard that?
Yeah.
So it uses the same process.
Yeah.
So a quick brief on how the artificial meat will be made. They pick the certain cells, certain proteins from either chicken or beef. So it was practically done in foreign countries.
Foreign countries.
So some geographical
Because
issues.
what could be like some vegan people are also wanted to eat that artificial meat or it's like
And the good thing about having the artificial meat, where it is actually eatable
yeah, it is eatable.
and it doesn't loses any taste of it.
It's the like taste also and the texture also it is also same. But
So it was practically happening, Cherry. So
but I don't understand why people wanna go for being vegan and still they want to eat meat.
and what about that vegan? I don't.
Vegan is like someone who only consume plant-based products.
Their main purpose is they don't want to kill animals
Yeah.
because that is very painful. Okay.
So I heard many terms on vegan, like vegan, non-vegan, and sub-vegan kind of
See, there are
things.
3 terms now: vegan, vegetarian, and
Yeah.
non-vegetarian. So vegan are like only plant-based. They only consume plant-based things. They also avoid consuming milk, dairy products.
Is it?
Yeah.
Yeah. And along with that, they don't even like eating those plants which you have to kill for
Kill
eating.
for it. They just like
Yes.
those who can be harvested like
Yeah.
over the surface, not the
like
grounded
see,
one.
if I am a vegan guy, I will only eat fruits, or I will only eat the vegetables which like tomato and all.
Yeah.
I won't pluck potato
Yeah.
because it is also it does kill those microorganisms and everything.
But
else.
that vegan term na, this is like very fancy. In our India, there is one
Yeah.
religion, Jainism. They
Yes.
always follow this
Yes.
from the traditional time.
I heard a different he defines vegan in a different way. So
Why?
I heard there is a guy. So he just saying that he was a vegan, but he consumes dairy product.
That means that person is vegetarian.
Not big.
But
Not
still,
vegan.
he won't consume meat.
I'm
So
also
that is
vegetarian.
vegetarian, right?
I'm also vegetarian and I'm also not consuming meat, okay, but I'm consuming milk products.
Okay,
I'm not vegan.
we are getting out of our context. Let's pop back into it.
Yeah.
So you are talking about decellularization. I was thinking, what is the peak of it? Like just like we are doing tissue engineering and all, right? So we can create something out of a single tissues, and we can create some new organs also if we
That's what
perform it really good. Okay. So what is the peak of this decellularization that we can achieve?
That we can achieve is the artificial tissues and organs.
Yeah.
As I said, just said the example like
Mm.
artificial meat.
Artificial.
So the process where it happens, they will pick out the certain cells from the chickens and from beef also like.
Yeah.
So,
So-
they can take meat cells and they can recreate it as much as they want.
Yeah.
Okay.
I mean, like, you guys have heard like people used to create a shape like a chicken for that soybean and then eat it like a chicken. Yeah, I have seen really.
Okay.
And yeah, and for that you are asking for that what is the aim of it?
Aim of it.
Yeah.
Yes.
So, like if we have, just imagine like if some person is undergoing for that kind of implantation or anything, okay, and that person having some issue in the bones, okay, that bone got cracked and that person is having for bone transplantation. So that person got a donor, or that person like we can extract from our own body also, that ECM, okay. But we can only get enough amount like 60%, 70%. But that rest 30% we can use that artificial.
Okay. So Dipan, it was your topic. Okay. If I got a liver transplant, okay,
Yes.
and my liver is 40% fine. So can I take my liver cells and recreate it so that I can implant it again and I don't need a donor? Is it possible?
Actually, for the
So as I was talking about it, like the liver transplant. So if my liver is 40% fine and I want those 60% extra liver, so can I take some cells out of it, then decellularize it, and then I again can I implant it so that I don't need a donor and I don't have to depend on anybody?
Yes. I think liver have a type of cell that we call T cells or B cells, no? That recreates in their own.
Yeah.
yeah.
If you take part of only 20% of the liver, na, it will create the whole one again. The liver.
Oh.
It's the only organ in the whole body. Na.
No, not only organ, skin is also
Skin is also there.
Oh.
Skin and liver
And
and
bone
bone.
also.
Bone.
These
They
three,
recreate their own.
only these three are have regenerative things in there right now.
And say like dissolution, we see basic term like this is a room. Okay, if we kick out everything like table, fan, chair, then after that the part we left na, that was called extracellular matrix. Then I will give an example. This is the process of dissolution. Like there's one thing I want to share that we all know spinach.
Yeah.
Spinach, you know na.
We do.
Like scientists are doing research on that. In spinach na, in 1972 they have started that research. In spinach na, they dissoluted the spinach and they use the dissoluted part in the heart tissue. The spinach only.
I watched it in YouTube,
Yes.
the whole color of it also gone and they use it as a heart
Yes.
tissue because it has the veins.
Yes, this is the main application that like you can know.
Yeah.
So and before taking break, I have a. Is there anything to say?
I want to share something techniques of dissolution.
Ah, okay.
Like there are not so long. There are three more techniques also.
Ah,
One is
yes.
physical method, one was the chemical method, one was enzymatic method. Like in physical method, the one that we use commonly it was freeze thaw cycle. Like they're freezing, then they're thawing. Like one part they're freezing and then again they're warming that part. This is one process of dissolution. By that we can create the scaffold. Like dissolution scaffold, they are little using each other. Like after dissolution, the left part was extracellular matrix, and when we use the extracellular matrix in the body, na, Then there comes the scaffold part.
Yeah.
So the 3D structure that we use.
So it's like
Explaining what
When-
is scaffold, he is the new one.
Okay.
You know what things cover what is scaffold?
As the structure, let us
Yes, it's the 3D structure,
I know.
like the basic structure of the any organs or system. Like before that, like doctors, when they transplant the human heart, before transplanting, they create the structure of that heart. Then they test on that part only.
Hmm.
So before touching the human body, they practice on that scaffold.
Okay.
You understood?
Okay, so if you have to, like, see, there are some confusions which I am having, okay?
yeah.
So if I have to explain, like, I am taking something out of this podcast, okay? If I have to explain a kid that what is decellularization or something, what are the 3 terms which I should use to explain?
See, can I tell you? Like dissolution, I have told now. Like remove decellularization, cellularization, and when decellularization means removing all the cells from tissues, all the cells from organs.
Okay.
That's the basic term of dissolution. Like I told that there's room. If you kick up everything out now, then the left part was that decellularization. This is the process of decellularization. And after decellularization, there's the only thing left that was called extracellular matrix. That's the only thing. That's the structure.
Okay.
So
What
first-
about you? What will you name all those 3 terms which I asked? How will you explain
if
a
I
kid?
had to explain this to our children, I simply said, if I cut your finger and if I want to replace your finger again there, but your finger got damaged, then after I use that product that is named as tissue engineering product, which is derived from decellularized matter.
Okay.
So then this is the part where I use decellularization.
Okay. What about you?
So since kids watch so much cartoons,
Okay.
so I will explain it in kind of like
Fun way.
a world.
Okay.
Imagine like tissue is the earth.
Okay.
Tissue is a house. In simple, tissue is a house where inside house there are so many things, tables, benches. So if you want only the table, you should only pick the table out.
Okay.
If you want only the chairs, you should pick the chairs out.
Cheers out.
And rest, you just stay there. It's like an empty room, making the room empty. There are two things need to be considered while doing decellularization. So one, if you want only cells, you should destroy the house. If you
This is something very violent. You are
Yeah.
telling us.
They're teaching a
Yeah.
kid.
So if you want only the cells, you should destroy rest. Or else you can just plug those in, but it's difficult. You can't manually pick the cells manually. So that's why destroying the entire walls is safe. It's better when coming to these kinds of techniques. If you want only the outer part, the matrix, the house, just throw all the things out. That's it.
See, if there is one oversmart kid and they ask why I am not able to pick chair and table together,
Okay, along with that, I want to ask one last thing, okay? That, like, if a person went to an accident or something, like, the accidents are really serious, your all skin tissues get torn off and very serious things, right? So, at that time, as he said, we already have our lattice, okay? I use lattice word because I am good at, like, chemistry rather than bio. So, we have already our lattice, which is room we were talking about. So, can we, like, build those things, right? All those tissues, torn up things, and we can take out all the unnecessary things which are the cells which are already dead.
Yeah.
We will take them out, we will remove them from the body, and all the things which are good, we will keep it there only, so that it can regenerate and heal
Yes,
itself.
yes,
it
Is
is
it?
like a wound healing. You are
Yeah.
asking for a wound
But the thing
healing.
is, see, sometimes last month I guess, I was in a hospital because my family member, they went through accident. So the problem was some of the things which are not required in body, or the cell which are dead, they stay in the body and they create some problem, like, in Hindi we call it that white liquidy things which are not required, fluid, all those things. So we have to take that out. And if there is a bone part which is like stuck or something, it will also create a problem. So can we take all those unnecessary cells out so that only the good cells are there which are required?
It is like a unnecessary thing that is building in that person.
Yeah, that is building because of
And
accident.
for for
and
that
all the
there
mesh
is a
tissues.
surgery methods. There is a surgery methods for that. We are not using deceleration things there. Like
Okay.
we can undergo for a surgery if the person.
I'm
has-
talking in a small scale. Like, see, you are talking about not muscles. I'm talking about the organs, because you cannot expect those organs to
Can I-
bend. Yeah.
Can I answer that?
Yeah.
So, for example, take the organ as kidney.
Okay.
If you have two kidneys, everyone knows of.
Yeah.
If one kidney fails, it will unbalances the entire organal system.
Hmm.
So doctors, they take out the failed kidney.
Hmm.
So entire human can function with even one kidney. Right?
Hmm.
So it's like picking out unnecessary things. It won't affect if their functionality was good enough with the one. If two were dead, then he should have some replacement for that.
Okay.
You got it right.
Yeah, I got it.
So anything else, Deepan?
Like one thing I want to ask, mostly to Jerry, like have you seen that the brain was taken out by doctor, then they
Yeah.
are discovered that part.
I have seen people working on brain, doctors and all, because we were studying about it, and my topic is about it also, right? So brain generally have 86 million neurons.
Yeah.
Okay, and all those neurons are really complicated. So you cannot just deal with whole brain. So you have to deal with each neurons which you want to change or affect. So that was
So
the
that's
thing
the
which we
question.
were studying about.
Can we that dissolution in that brain? Can we do the
Yeah, we can do if we are just picking a building block, right? A single cell.
Single cell.
So we can, I guess we can.
What was it?
What do you think?
What
What
was
is the real answer?
The answer was his answer was still researching on the science.
Like I didn't get, bro. I was kind of zoned out.
Yeah. See.
See,
Okay.
see, brain. Can you do the dissolution on the brain? That's my question.
Okay.
Yeah.
I guess because it's made up of cells, right? Neurons and
Can
those
you
are
take out the
cells.
cells from the brain and then you will put it again on the brain, on the head?
No, we can do, I think.
I guess if it doesn't reject, you can.
I
Hmm?
don't understand. Still, I don't know why.
Confusion.
Okay, like you are talking that some organs we can perform decellularization, in some organs we cannot, right? So you already told about liver we can perform, kidney we can perform,
Also, that's
and
what
some
brain you
things.
can
But
perform.
for the brain, we don't know.
And
The research is still going
Still
on.
work. And
Oh,
so
so-
that's the answer. See, I'm asking that like heart also we can do dissolution,
Hmm.
kidney, liver, skin, everything.
Hmm.
The brain is still on working on that. We can't do dissolution of the brain directly.
So the negative thing for that, we are still going through the trials
Yeah.
for the deceleration of
Yeah.
brain. And the main complication was all the cells can be able to regenerate. That's the main disadvantages.
No, it can't.
All the cells are not
No.
not able to regenerate. So when coming thing to the brain, it should have some environment to grow.
You guys are talking about regeneration, and I keep thinking about Wolverine and Deadpool.
The movie was good.
Yeah. And regenerative properties, though, our HODs have told us in our class that only
Yeah.
3 things can be regenerated, and apart from that, we can't regenerate anything
Yeah.
after coming out from our mother's womb.
So that's
That's
the
it.
answer for that. I think
Yeah,
that's the answer for that.
that's that.
So before going to the Cheryl's topic, before taking break, we have trivia question.
Okay.
Okay.
So since he's our team member, he
Yeah.
already knows how the trivia works, right?
Yes, I do.
So we'll directly go into the trivia, or else if you are doubted on that, we'll give a
You can
short
explain it again for this podcast.
If you are clear that, I can go for the question.
Yeah.
Okay, I can go.
Fine. Okay. So in 1992, a team introduced allodal. So it's the team where works on the decellularization of human derm products, and that has expensive cells on it. So it was a very complicated process.
Yeah.
They just started it on 1992, and it was the kind of geographical question maybe. So and what's the corporation that introduced the algorithm in 1992?
What's the concept?
Corporation.
The company, right?
The company.
The company has introduced it.
So
Options?
options: stem done,
Stem?
done,
Down.
cell done, life cell, and tissue cell.
Sanjay.
So these are the 4 options.
Mm.
Answers will be revealed at the end, guys.
Okay.
So before going to the topic, we'll take a small break.
Guys.
So welcome back, guys, and now will be the Cherry's topic.
Okay. So before starting my topic, I will explain a bit that what is my topic. We were talking about decellularization till now, and sorry. So we were talking about decellularization for now, and it was really complicated for me also. But now the topic is about quantum computing and how does it affect our biomedical field. So when they invited me for the podcast, I was thinking that what are the things which can improve biomedical field and biomedical engineering from an IT perspective. And then I came across quantum computing, and then I came with a research paper. It was from MIT and Dr. Elena. I cannot pronounce her name properly, sorry for that. But yeah, Dr. Elena, and she was doing a research on the topic that Alzheimer is a disease, and on that disease, she wanted to know everything about the disease so that she can tackle it. So basically, it is like, have you heard about viruses and HIV viruses and all those things, right? So all these viruses, if you can somehow you manage to know all the component of that virus or any virus, you can tackle it, you can kill it, you can like save it, you can recreate it, whatever you want. Okay, it's just like you know how to make a phone or how to build a phone, then you can build it on your own by gathering all the components you need. Similarly for the cells also, if you know earlier there was coronavirus, right? People took like approximately 1 year to just find out how the virus is, what is the structure of the virus. Okay, because it is very small, not even in nanometers. So it is very small. So if you want to understand those structures, right? If you understand it somehow, you will, you can whatever. If you want to kill it, if you want to reproduce it, if you want to save it, if you want to use it for some other purpose, you can do it. You can manipulate it basically. Okay. So now let's go back to the research. So she was doing research on the Alzheimer, and that to tackle it, she need to unfold protein. And you already know that protein are of different types, like single folded protein,
Yeah.
and then double, and then triple. Okay, and it was in class 11th, I guess. No, class 10th bio book, right? It was there. It was all 4 protein structures were described there. So she was doing research, and to unfold a protein, it's very complex. A protein structure is very complex to begin with. To unfold it, a supercomputer of current age also takes approximately 1 to 2 years to fold it one time. A single time fold take 1 year, and that is totally useless. You are giving 1 year for a single fold, and if you want to fold it completely, you have to give at least 4 or 5 years just for that. Even if you are using supercomputer, right? That is the best computer humankind have till now. So, but when you introduce quantum computing in it, the same 1 year span for folding a single time a protein, it reduces to minutes, 1 minute. And if you don't know how quantum computing work, from my background, I will explain it a bit. Everybody talks about it doesn't work in 0 and 1 and everything, but everybody says that it is in superposition and entanglement and all those fancy terms. But basically, it is not true. It is not in 0 and 1 state, it is a probabilistic state. Okay, if you say that my bit, or in quantum computing we call bit as qubit. My qubit is 0.75% in 1 and 0.25% in zero. So you can get more states out of it. You know probability, right? We already study SRP and all those things. Those are fascinating. So
Fascinating.
okay, so because SRP is when you guys, if you don't know, SRP is the core of quantum computing. If you
Yeah.
don't know how to deal with probability,
Yeah.
okay, you cannot deal with quantum computing also. Okay.
Yeah.
So what was I saying? There is a method that it is in superposition and all. It has conditions, it has probabilities, and then there are matrix multiplication and all those things. Leaving those things aside, let me tell you the advantage of how a quantum computer or how our quantum computing brings changes in our biomedical field. So like basically, if you want to prepare any drug like paracetamol and all those headache and all those drugs, from starting main cause, making it, how we tackle it, how we make it, okay, all the procedures, and then using it and seeing like what are the side effects and all those things, we take approximately 10 to 15 years just for making one drug.
One drug.
Okay, and approximately like $2.6 billion investment. That is a big amount, and it is in dollars, not in rupees. Okay, so we can reduce all those years in just days if we use quantum computing for it. Then we are talking about DNA analysis. You are talking about that our body rejects DNA and all those things, right? So the thing is, if I want to get like a liver, like sorry, I'm stuck towards the liver, but yeah, if I want to get any other organs or something, how do you check that the DNA is compatible or not? From current computers, if you check it, it takes months,
Months.
sometimes years to just check the compatibility of your DNA and your other things. But if you're using a quantum computer, it's just for minutes. Okay? Yeah. Then we are talking about neural networks and all those things,
Yeah.
which are like basic building
Basic
blocks of
building.
AI and all things, right? If you integrate a quantum computer, that processing power to a AI, it can give you all those like particular data which take a lot more time, okay, to get access from a normal computer and the LLM we are running for now.
Yeah.
So if we are building a natural LLM, okay, if you don't know the basic thing which is used how should I explain? Okay, so the quantum computers for now are just used for natural processing. Okay, like how we can see a molecule, how can we see a cell. So all these simulations are better run in quantum computers rather than normal computers, classical computers. Those are very slow in it. So if I prepare, like he was talking about that cell manipulating and all, right? You can simulate it in online. There was one very good research. I won't say research. It was an experiment. Okay, so they created a frog. They included all the traits of a frog in a online simulation. Okay, then they tested drugs on that, and all those results they made it like a list. And they said like if I give it a parasite, I'm just giving an example, like if I give him a tablet or a drug, how will it affect the frog? Okay, so they simulated all this thing in a quantum computer, and then all those results were checked that on a real frog, and those results were approximately like 90 to 92% similar. So if you can create somehow a human structure in a like simulation, then you can try all those drugs you want, and you don't even have to kill, or you don't need a real human to test on. So these are all the advantages of using all those things. But if apart from this we are using current technologies for it, you need lot more time, and time is money. Time is very valuable. Just like in Corona, right? If we have the technology, to use quantum computer for that, we could have saved lot more lives than we saved now.
Yeah.
Okay, then medical imaging and all those things. You are at podcast number 2. I was also there. Okay, you are talking about MRI scan and all those things. So in MRI scan, it takes 30 to 60 minutes for a single scan. Okay, but that time can also be saved in seconds if you use a quantum computer. Okay, apart from that, there are some predictions. These are not real for now. These are just predictions that you can also make a custom protein. Like currently we are just researching on the protein which already body have, right? But when we are talking about tech which we don't know now, like if just suppose some alien come and invade us, right?
Yes.
Okay, it is very like well, you can say it's very hypothetical thing, but just in case if they come in, there are lot more science fiction films on this, right? If an alien come and invade us, we are not going to waste years just to analyze his body structure, right? If somehow we get a dead alien or something, we can just easily like know if you are using these computers, right? In minutes or seconds, you can know that what is the structure of this alien. Oh, if we use nitrogen, we can easily kill this animal. So we will just pour nitrogen and that animal or that alien will be gone. So all these features will save human life. We can also develop it further. Like if we develop somehow some proteins which doesn't need much more oxygen or much more I don't know the term, ATP, right?
Yeah,
Is it ATP which is the energy of body?
Energy.
So which uses less ATP for the production of their things and all. We can be superhumans. We can develop some skills like Spider-Man. You have seen all those claws. He can climb in wall. We can develop that using if we develop custom proteins. Okay.
That's what we talked about in the second podcast.
Yeah.
About the superpowers.
Superpowers.
Just we need to turn on the switch.
I have one question, like how do you said now that we can create that particular drug,
Yes, yes.
and then is there anything that by which we can deliver the drug directly in the body through the quantum computing?
Okay, so basically it's like a simulation. Okay, I will tell you one thing. If we want to make a drug, for like we first check. You already know chemistry very well, you all guys. Okay, so if I have a benzene and if I want to add a CN or a cyanide, CN, I have to make some all those research and all. I have to do all those things. But if I describe a quantum computer that CN does this things, like this is the working process, like how do we react with some kind of ketones and aldehydes, how does it work? It will analyze that is it a ketone, it is cyanide, and it will work accordingly, right? It is a hit and trial method kind of thing. But if we go in laboratory and we try to perform it, it will take us a lot of time. But if we just give a command, okay, I have a benzene, I have a cyanide, just mix it and tell me what products can I make out of it.
Basically, without doing any practical
Without
work,
doing any practice.
we directly
Yeah, it is a,
doing that
and the
within
main thing is
system.
it is a isolated system. You don't have to worry about like if oxygen or if
Yeah.
humidity is more or less.
Yeah.
You can also fix it that this is the humidity, this is the parameters. So now if I want to make a drug, okay, it is mixed up of very like so many chemicals, right? So I can just give a prompt or a command and it will analyze all those like all those chemical combinations which are possible. Yeah, like if we have to combine like 3 or 4 chemicals, right? We have to think about how will it react in 15 to 20 ways. So for all those chemicals we are talking, there are a lot more combinations, like in millions or billions we don't even know. So this computer will do it in minutes. If we perform it in lab, it
Yeah,
will
like-
take years.
Like it will also show the consequences. Like if we randomly
Yes.
want to do something, randomly we want to mix up 2 chemicals,
2 chemicals.
and then we want something to some like product out of it.
Out of it.
But if that product is not good for us, then it will show the consequences of it also.
Yeah,
along with
it depends upon how you make the software, na. I'm just talking about the computation power here.
Yeah. Okay.
Okay, you got it.
Yeah.
I'm
And
talking about the computation power,
Guys, since the simulation software, so medical side completely, simulation was the proper tool where can explore many more things in an isolated condition. So it
Okay, I will explain on you guys in a simple way. Okay, I was talking about benzene and cyanide. Do you have benzene and cyanide now?
No.
No.
You cannot perform it. You have to go buy all those things. But you have your laptop, right? You can just type it. Here is benzene, here is cyanide. Cost efficient, time saving. Okay, and you don't have to run. You don't have to
Easy
worry.
work.
Yeah, easy work. And then if you like came to a conclusion, yes, this is my compound which I want to make, then you go and buy it. Otherwise, all those
Perform the
research
things
take
after that.
billions of rupees. Okay.
Okay, I have a question.
Yeah.
See, like you have to use quantum computing now.
Yes.
Like there's a one term in physics also quantum physics.
Yeah.
As we know, the quantum physics is the most toughest in the subject, toughest topic in the whole world. If anybody tell that I know quantum physics, there are 2 options. He will be mad, or others he will know everything. Like how that quantum computing, why it was quantum
Okay,
computing?
yeah, it was it. Okay.
Like quantum physics is quantum
So-
is it's nanoparticles or nanotron. Like what is
Just like I am trying to integrate IT into BME. People also tried to integrate physics into IT. And then they came to quantum computing.
Yes.
Okay.
Physics into IT.
Yeah.
So,
Earlier we used transistors.
Many of the guys having doubt that quantum computing, how they termed it.
Yes.
Okay.
So how
I
they
will
termed
explain.
Is it tough or
So earlier in classical computers we used transistors.
Yeah.
Okay. And it is 0 1 and it was also a great invention of that time. You know why? Because earlier people used to use mechanical things. Okay. And in mechanical things you have to turn it on and off and all. Right? But in transistors you can just give a little amount of right amount of voltage and it will turn it on and turn it off. And that was the invention of that time. Okay. Then we came to a quantum computing as I was talking about that physics we are using all those particles. Okay, I don't know the proper particle names, but there are different particles and we are using qubits. Okay, so it exists in a probabilistic state which is a part of physics only. The if I can show you images or something, you know that quantum computer looks very different from the normal computer. And there is one more condition there that you have to cool it very much.
Yeah.
Out of curiosity, I just typed in ChatGPT that how to make quantum computer, and I was believing that if I can make, I will make. Okay, it can be my project or something, and then it said that it requires 249 or something, which is 1 degree above the absolute temperature.
Absolute temperature.
So I was like, I cannot achieve it. Let it be.
But I have heard that qubits you're talking about, it's very fragile. Like
Yeah, they are very fragile. That's why you have to keep it in a very cool environment.
cool environment, and it is
those qubits are elements only,
Yeah.
which can, because see, we are trying to manipulate physics, okay, physical states from our knowledge we are having now. So if somehow we get a better knowledge, okay, from this only, this also I will tell you one thing. We are talking about quantum physics and all, no? So scientists, they used lead and they created gold AU by removing 3 protons from it.
Yeah.
So that
It
you
has
know that
seen
research,
it.
right? You know that. So they removed it. So if you have seen all those fascinating movies that where they create nothing out of water or nothing, right? Out of nothing. Okay, sorry, I like they create sorry. They create water, fire, all those movies out of nothing. Okay. So you can create similar things. If I have this tissue, okay, I can make, if I know what are the component of it, I can put it in a tray or something and then I can create gold or diamond out of it. If I know how to make it, okay.
Yeah.
Because those are just combinations of proton and electron, right? And then they mix up with other components and show us the thing. So there is carbon also, if you know, okay. If you somehow manage to increase the proton in it, electron will automatically come because electrons are everywhere, okay. So it will automatically come and then you can create oxygen. Then you don't have to think about oxygen. You can just take this much of carbon and then you can create oxygen out of it. So all these things are related to physics which are being implemented in our real life or our IT. Then quantum computing is an example of that only.
So for quick guys, it's like as of now there is a topic came that they extracted gold out of lead.
Yes.
So it's general physics like our body has some proteins. When you pick it up, it's like gene editing. When you don't want, and when the certain DNA parts were causing issue, you just pick out those genes out of the DNA. Similarly, when this conversion between lead and gold, it's a physical matter where it's constructed using atoms in it. So when every element has certain protons and electrons in their bond, so when you pick certain electrons out of it, so it gains the property of another thing. So like as of here, lead has certain electrons in their bond. So when you pick the electrons out, I thought it was electrons or protons.
protons?
Protons. You have to eliminate 3 protons.
So
that you can
3
get
protons out.
blue gold.
That's why I got confused on
Yeah.
that. So when you plug out the 3 protons, it gains the properties of the gold.
Yeah.
So it's like similarly our gene editing.
Yeah.
So we probably talked about that gene editing in third episode.
Cherry, have you heard about that CRISPR-Cas9 gene therapy or gene editing?
No.
That also happens with the computing.
Computing.
Yeah, that quantum computers are also using it to remove the genetically presented diseases that
Yeah.
comes from the
There is
generation.
Cas9,
Yeah,
yes,
CRISPR
Cas9 and CRISPR. Yeah, I was
Yeah.
I was going to tell about that. Okay, so there are nanobots. Okay, but nanobots for now, the data of the chips they are having, because they have to work, right? They are just robots which are of very small
Very
size.
small.
So if they have to remove something out of genetical engineering was talking about, but what I heard was they removed HIV virus
Yeah.
from a
From a person.
from a person.
And
people-
99.9% they
Yeah.
got success in
Yeah,
it.
they got success.
Last week they
So-
only got.
Last week,
Yeah.
I don't know the proper date. Okay,
Yeah.
but the thing was they removed it. But the main problem in nanobots are their computation power is really slow.
Yeah.
So somehow if we can integrate our quantum computing or the chips of quantum computers in that,
Mhm.
those small chips can contain more data. It's just like earlier we used to carry all those big disks, right? Then there come pen drive. So earlier disk was having only 1 GB size, but pen drive can have 512 GB size. So the more you can make it compact, the more data you can feed. So the chances of getting failed is very less, and the efficiency increases widely.
I have one more question.
Hmm.
There is one term in quantum computing that is called cryptography.
Cryptography.
And that
is-
cryptography and that CRISPR-Cas9, is there any similarities between them?
Okay, so cryptography, tomorrow only I did my practical on it. Okay, so cryptography is a method like how you protect some data. If I give you a data, like maybe it is a data about Dipayan. Dipayan got 20 marks. Okay, out of 20 in his
Topper.
midterm.
Oh,
The topper of the,
already.
yes, he is already topper. But he doesn't want to reveal his marks.
Yeah.
Okay, so we will make a language, we will make a cryptographical representation of it, where his 20 marks will be represented by something called 109856XYZ. Okay, and that data is very unique. That data can only be decoded by the cryptographic technique only. Listen
Okay.
properly. Okay, if you also got 20 marks,
Yeah.
and your data also get converted into
Yeah.
cryptographic technique, right?
Yeah.
From cryptographic technique, your data gets converted, but your both the output will be different. Nobody can decode it. It is 20 marks, the same thing, but both data will be different because there are like 2 to the power 2, 5, 6, 8 or something combinations which you can think about. Okay,
Of a
of a particular thing.
Like
And
there
cryptography.
was a movie also na, in the cryptograph, there is a war was going between America and Japan. They are doing cryptography like this.
I would like to add one thing. Okay, the Cold War thing, if you're talking about, I don't know, but when it was a war between Japan and USA when
Yes,
bombed
yes,
and everything,
yes.
right? They were at that time also very advanced in technology. Okay, so if they can every digital thing, like from your laptop to aeroplanes, they have a digital trace. Okay, so they used to communicate. Okay, they used to communicate through radios and all those frequencies. Sometimes you have heard like in movies also they get a random frequency and two people are talking, right? They catch a random frequency. So for those things, like you want to transmit a data, but you, even if your opponent or enemy gets the data, they cannot decode it. That's why we use cryptography. Okay, and there are 5 techniques. I will explain it, but before that I will come to that point, like the Japan thing and all. Okay, so earlier they don't used to do this all that computers and all are that much important for them, right? They were like we want better weapons and all those things. You are focusing on that, but then when they get to know that a computer is way faster than a human for computation power, okay, so they use a computer to decode the signals they were getting from aeroplanes. So now they can hear what Japanese people, now they can hear that what are those people who want to bomb, which area they want to bomb, and where are they leading to, how much fuel they are having, and that gave them an upper hand. But the problem was they get bombed and the nuclear attack was there. Apart from that, those were the technologies, okay. And now if somehow, okay, quantum computing is really good for this thing. Somehow, if I get a quantum computer, okay, and if I want to mine Bitcoin, I can mine all those Bitcoins in minutes, where the other people are taking days or years for it. But I can mine all those things in very
But
few.
for the setup of that quantum computing, it is very expensive. Like, if we want to mine a Bitcoin, I have heard like you need very big setup to mine it.
It's because, see, if I want to mine a Bitcoin
Bitcoin.
from this computer, he has to do 1 billion or 1 billion or 11 billion computation, okay,
In a-
just to get one, and it doesn't support that speed. Nobody's laptop or that doesn't support that speed that it can generate those strings, check it that is it already existing in somebody's wallet or something, and then you come to a conclusion that it is a new Bitcoin, right? So all this process take maybe minutes or something. Now you divide this minute by a billion, and then it will take 300, like I don't know the approximately time, but 100 200 years for mining all the Bitcoins, right? I am just giving a rough idea. Okay, so but if you are having a quantum computer, in all this time or all these minutes reduced into 0.01 second. Now even if you multiply it by billion, you will save a lot more time.
Yeah.
You are like saving 200 years in just 10 years, and now you are rich. You don't have to.
Within 10
When
years.
other people are just dying, okay, to mine one Bitcoin, you are already having 10 Bitcoins, and then you can improve.
Yeah.
The main thing is computation power. If you increase it somehow, it is really good.
But what about that CRISPR-Cas9? You said that cryptography, like for the divine, he got
Mhm.
20 marks and he got that result, but he don't want to reveal it.
Reveal it, yes.
Yeah. But in CRISPR-Cas9, we also have like gene strands and like different names over it. So like how you will relate that CRISPR-Cas9 with cryptography? Do you have anything to say about it?
Okay. So cryptography is just like okay. Let me think of a good example. Okay.
Yeah. Okay.
So if you want to burn water, okay, you just give it heat, and then it will convert into
Vapor.
vapor, right? If you are giving that same heat to a paper, it will burn and it will turn into
Ash.
ashes. If you give that same heat into his body, he will burn, his tissue will burn, and it will, I don't know, you know better,
Liquid,
right?
it form first
Yeah?
liquid, it form to liquid.
Yeah, all those muscles, if you burn it, right, it will make something burn tissues and all those things. Same goes for cryptography. Cryptography is basically mapping. You are mapping your data into something secret or something which you don't want to reveal. Okay, for my case, which I was talking about. But for this thing, you are mapping all those nucleus, okay, all those nucleus or all those protein data into something which you want to use. Because see, if we are making, it's just like a flowchart. Okay, let's explain it through a flowchart. This is your basic protein, and then you are making it as a tree. Okay, only few part of those protein will be different. Otherwise, rest will be same. So you can categorize it. That is also the mapping, the graphing. It is also called cryptography. Okay, you got it? What I want to say. So for my case, it was mapping it through a thing so that I can hide it. My purpose was different, but the procedure was same. For you, it is making a tree or making a like set which is similar. Okay, got it? You're getting it or not?
Yes, yes.
Okay, see, you are having a billion combinations of protein, and now you cannot have all those billion combinations, right? If you want to study it, you have to group it. Just like we study animal kingdom, plant kingdom,
Yeah.
all those things. Like you have different subjects. Those are grouped concepts or grouped topics which are similar to each other so that you can understand. Similarly, if you are having a billion combinations of proteins, you have to group them so that because see, if I am studying a protein which is 1% different from each other in a one group, okay, it will be easier for me because rest are same, fine. But if I am studying one which is 99% different, then one which is 1% different, then one which is 30% different, it will particularly the study of it gets hard. So for that we use cryptography to map it, okay, to map
For
it to
easy
make a good,
understanding.
yeah, for easy understanding and flowchart. So when you feed it to a nanobot, that like this is the implementation of this, okay. When you give it to a nanobot, okay, now you will give that set which has only 1% different protein, other that 99% protein are similar to that, so that you don't have to feed that nanobot with every data you are available with. If you want to fix some virus or if you want to fix jaundice virus or something, right? I don't know if jaundice virus is there or not.
Yes, it's a
Yeah,
virus.
Yeah, there is virus, right? Or malaria virus which is
Yeah.
injected. If you want to treat that virus, you will just feed that nanobot that data only.
Yeah.
So for that you already made a good chart that this data, this protein
Just
data
need
is
to
for
feed
this,
that
and this,
information
yeah.
directly. Okay.
What was that CRISPR case 9 like?
It's a gene
You-
editing.
It's a gene editing.
It's a gene editing, but you linked it that to cryptography,
See,
right?
if you want to edit a gene, right, you're using a nanobot, okay, but you cannot feed that nanobot with every data you are available with about these things. You have to feed that bot with particular data because its storage is also very small. Okay,
So,
for that you use cryptography, which makes you a flow chart or a better understanding about that problem only, so that you can only feed that data to the bot. You got it?
it's like using whatever data we want for the particular task.
Particular task. Yes.
That's
It's
all.
like a liver cell for liver, kidney
Huh.
cell for
Or
kidney.
kidney.
So it's same applied for the.
You're not going to use a nanobot which is made for liver and
In heart.
Oh,
Yeah,
okay.
in heart.
So this makes easier to the gene editing. Right?
Gene
Targeted drug delivery, you can say. Targeted drug delivery.
So okay, it's a lot, guys.
Yeah.
There are so many combinations of genes also.
Yeah.
Right?
So I just really quickly want to say that you know about DeepMind, right?
DeepMind.
Google's DeepMind.
Deep mind, yeah.
So they uses a simulation software, same as of now we talked about the simulation, right?
Mhm.
So by simulating a software like certain algorithm to the machine, they reconstructed over 200 million proteins. Where 20 of 1 second guys, where 20,000 of proteins all from the human body. So here it happens like the machine randomly checks, creates new types of protein with wide range of nucleic acids.
Yeah.
Where then they cross checks what are the proteins we find, what are the proteins were in the body, and what are the things that are matching. So I just really think that 20 million is such a number.
Yeah. And how
Sorry,
is-
it's 200 million.
How much time does it take?
They didn't actually mention the times, but
If they
I
give
don't-
the time, then we got the time, accurate time, like how much time we can also do that. It's like
so
that.
time like constructing this amount of data, it definitely will take some time.
Of course, it
So,
will take
yeah.
some time, but yeah, okay.
They didn't mention it, so I'm curious to know about the time, but they haven't mentioned.
Yeah, even me, I'm so curious about that time because last, I don't know which podcast you have told me about one topic by which that is also related to a Google, that thing that solved one problem by 1, 2 or 3 less steps
Yeah.
that were
New
initially-
discovery.
Yeah, new
of
discovery.
Alpha evolve.
Yeah, alpha evolved.
Yeah.
And
Not
Here they are using the same alpha evolve. So it was like not this timings. It was found at past just before 6 months or something.
just that one. That
This
is
one, the construction of 200 million proteins.
Okay.
So
No.
they simulated a
For
software.
the first protein to be unfolded, it requires 21 years
21 years.
by humans
Yeah.
just to unfold one
Unfold
protein.
one protein
Okay.
by quantum
Yeah.
computers only now.
No.
Yeah.
By normal humans.
Yeah.
For first, I'm talking about the first,
Okay.
where computers and things were not existing.
Oh.
To unfold first protein, they took 21 years just to fold one protein.
But quantum computing also did that protein folding now.
So when like scientists wanted to unfold the first protein, okay, in 1800s, they took 21 years to unfold the first protein. Then for rest 100 years, only 21 or 22 protein were known to human. And then comes computers and all those things which evolved very quickly. And now he said, all those years, 121 years, only 21 proteins were known to human. And after that, just in maybe 10 to 15 years, right? Now we know 20, how much?
200 million
200 million proteins.
Oh.
They discovered.
They discovered
They
it.
discovered.
This is the power of computer, and now think if all those systems will be run on quantum computer where computation power is so much,
So much.
they can achieve such targets which you cannot even imagine.
So much potential.
So this how it will be. I'm very curious to know about the time.
Yeah.
So they haven't mentioned it. If we found, we'll definitely get to know you guys. And they actually made a bond with the Oxford University also.
Yeah.
University of Oxford, and they used AlphaFold models, where Google is such a big company where they specifically do different kinds of things. For each thing, they have some certain specifications for that accordingly. So, I think they are the one who are doing this stuff. Not only the browsing, not only the browsing. So that's all about I want to say.
Yeah.
Anything else, guys?
You were talking about browsing, right?
Yeah.
Google also took more than 14 years or something just to reach 20 million search. Okay, and in ChatGPT, it took only 3 years.
I really feel
True.
that. Yeah. I really feel that Google have the proper result algorithm. Like users are very specified about the results. When they have something to know, they should go only for the specified and verified source. So the Google was constructed in such a way that if you want anything, in most of the 95% of the cases, the result you are getting from the search was exactly that.
If you write anything,
Yeah.
anything which comes to a human mind, if you type it in Google, you will definitely get answer.
Like literally 95%. Like new discoveries may take time to reach.
Even if you think like our college name, right? If you reverse it and just put it in Google, you will get answer. Even if you include X, Y, Z in between, you will get answer.
They
And
got
it
the
will be
keywords,
accurate
yeah.
according to that.
They got the keywords.
Yeah, they got the keywords.
They got the algorithm properly.
Algorithm keywords.
Like the
yeah.
search. So that's all about the today's episode, guys. And before ending the session,
Trivia answer.
trivia answer. So, as I now said, what was the corporation company that introduced Allodum team in 1992? Answers.
What is it first?
The first one.
First, Harshita.
I feel it's life cell.
Yes, mine is same lifestyle.
Lifestyle.
Mine one is the first option, STEM wrong.
Stand down.
So, Cherry was wrong,
Okay.
and Harshita and Dipan was correct.
When it came,
So, they started the corporation where it's located at Algerian or something. Yeah, I don't know exactly. And it was the FDA approved thing. They are running in a proper licensed.
It was that company was running till today also.
Yeah,
I
yes.
have, because last night I was reading one research paper, and where I found that there is one company called Life Science. It gives tissue engineering products. It produces that particular things, especially the bone tissue engineering.
These are very useful, guys,
Yeah.
because if things get to know where this are coming from, you can easily get access to certain things.
Yeah.
So since this had the lots of experience, you can go check their website also. Is it their right website?
Yeah, it is there.
What
And
is website I'm trying to find?
Life Cell.
Lifestyle.
Stem cell banking.
Life Cell company. A corporation.
International private limited.
Yeah.
Yes.
Yeah, that's all about the today's episode, guys.
Yes.
So thank you, Dipan. Thank you, Harshita, and thank you, Cherry.
Yeah. Thank you, everyone. So.
Thank you.
That's it for today's podcast. Hope you guys like it, and if anything we said in this podcast is wrong, then please pardon us. We are also students.
if you have any question, then comment us.
Bro, what was that message? Low battery, right? Okay.
Yeah, that's fine. So the last thing, as I said, if you do have any question, do comment, do ask things, because all these conversations make our knowledge grow more and more with every podcast and with every discussion.
Okay,
So thank you guys.
Thank you, guys.
And see, we are having some thoughts in our mind. We are just trying to express it. If it's wrong, accordingly, because when the time changes, new things happens. So we are discussing already happened things.
yeah.
So try to convey with us. And if you have any questions, any doubts about the topic, we'll get to know in the comments. And thanks to Shekhar Roy sir, our HOD, for allotting the studios.
Yes.
And thank you guys.
Thank you guys.
That's all about it today.
Like, share,
Bye-bye.
subscribe.
We'll see you guys in next episode.
Bye.
Things need to be considered while doing decellularization. So one, if you want only cells, you should destroy the house. If you
This is something very violent. You are
yeah.
They're teaching